Hello, this is a quick help video for a few problems on homework number 3B. So question number 7. A quick quiz consists of 2 questions. First, multiple choice with 6 possible answers, then true, false. If both are answered and are random guesses, find the probability that both responses are correct. Round your number. So we have a quiz with 2 questions. Question 1. 6 possible answers. So I have a 1/6 chance of getting that right if I guess randomly. Question 2, 2 possible answers, true and false. So I have a 50% chance of if I guess that randomly. Now this has to happen in order for me to get the probability of both correct. You can think of this as first, I have to get A correct, the first one. And then, whenever you hear and then, it's a times, B correct. So this would be 1/6 times 1/2, which would be 1/12. I hope that makes sense. Question 2. Suppose a math class contains 34 students. So I'm going to draw a math class that has 34 students. I'll make a little diagram here. 34 students. 15 female. Here's my female. And 19 males. 9 males. All right? All right. And of the female, 2 speak French. So now I have French. This is my French group. Of the females, I have 2 that speak French, so that's 2 out of 13, or 2 out of 15, so there's 13 that don't, 2 that do. Of the males, 6 speak French, and that's 6 that do, and therefore 19 minus 6 is 13 as well, 13 that do not, right? So let's take a quick look at this. Compute the probability that randomly selected students speak French, given that the student selected is male. So if I'm given that the student selected is male, I'm only looking at this circle right here. And that's 6 out of 13, or excuse me, 6 out of 19. Right, 6 out of 19 total. Let's take a look at this in a table form. I have French, no French. I have female and male. Total of 34 students. Right? Total 15, 19. Notice that this adds up to 34. Of the French for students, 2, 13. Right? 6, 8, adding totals. 13, because that has to add up to 19, 26. Notice that 8 plus 26 equals 34. Now, given that I'm male, select random speaks French given that male. As soon as they say given that, then we only look at that row, male. So that is French out of total males, 6 out of 19. I hope that is helpful. So now we're going to do this lottery game problem. All right, so I want you to think of this problem as there are 48 total numbers. Right? So from those 48 total numbers, 6 are winners. So think of this as 42 losers, 6 winners. Okay? And then you go and pick some. And in order to win second prize, you have to pick 5 winners. And then you pick 1 loser. So, of the 6 winners, you're picking 5 of them. You're not picking 1 of the winners. So this is kind of what a graphical picture might look like. So, first thing I have to ask is how many ways could I just pick 6 numbers from 48? What's the total possibilities? So 48 choose 6. This is a combinatoric, so you can do this on your calculator. You can do it on Minitab under combinations, or you could go to, just go to Google and type in combinations calculator, and it will calculate this for you. If you're on a TI-84 calculator, you would go to the math button, then you go to prob, you choose, I think it's number 3, which is combinations, NCR, and then you put it in 48 and choose 6. If you were doing it by hand, this would be 48 factorial over 6 factorial times 42 factorial. And when you work that out, it should end up being this number. So this is our denominator, this is our total sample space. Now, we want to know how many ways I can pick 5 winners from 6. So there's 6 winners, I'm going to choose 5 of them. Right? So that would be 6 factorial over 5 factorial times 1 factorial. And that works out to just being the number 6. So there's 6 ways I can pick 5 from 6. But I'm not just picking winners, I'm also picking this one loser. So this one loser right here. So how many ways can I pick that loser? That would be 42, choose 1, which would be 42 factorial over 41 factorial, 1 factorial, which would be 42. Now, we're going to calculate the whole probability. All right, so I have 6, choose 5. Those are my winning numbers. My 1 losing number. I have to do this and this, so it's a multiply. And then divide that by my total sample space. I'm going to take a moment for you to just take a look at this format here. Notice that these 2 things add up. Notice that these 2 things add up. This is called a hypergeometric problem. There's an E there. Geometric problem. And they'll always have this form where the first 2 things add up to your total, the last 2 things add up to your second one. So when we do these numbers, we're going to have 42 times 6 on top. So 6 times 42 divided by this. And they want this as a fraction. So we reduce that to 21 over 1,022,626, taking out a common denominator or a common factor of 12. So this would be the answer that they're looking for. I'm sure they do not want the commas in it. Hopefully that is explaining how to find the problems for the lottery problem. All right, so this is the final problem we're going to look at. This says the table summarizes the results from 880 pedestrian deaths that were caused by automobile accidents. And they're asking, was the driver intoxicated or the pedestrian? And the 2 different pedestrian deaths are randomly selected. Find the probability both are involved. The pedestrian was intoxicated. So we have the probability of the first times the probability of the second. So we're going to go ahead and take this out. First, we need to know the total number of deaths. So the probability of the 2 different pedestrians randomly to find the probability both involved pedestrians were intoxicated. Right? So here we go. Right? The probability of a pedestrian intoxicated is this number over our total of 980. So that total there. So we're going to take 59 plus 224 283 over 980 times And since we have finite data, I'm going to go ahead and assume they're taking the first one out so we don't double count them as we're randomly selecting. It's not super clear whether or not this is requiring replacement or not. So our next one would be 282 because we took the first one out over 979. So we calculate this as a fraction and put it in a percent. So 283 divided by 980 is 0.2887751. 282 divided by 979 is very similar. It's just only off by 1 on top and bottom. And times that, times those together, because we're doing this and that. We should get 0.08318. Only want to two-place accuracy, so that's just going to be, well, two-place as a percent, so it's going to be 8.32%. You don't put the percent sign in there, but this would be the number that they're looking for.